Hey there, you're watching the Aussie BIM Guru, and today I've got a user request. Someone recently asked me how you can get a bounding box in a geometric environment that is aligned to an element, which is quite a common challenge that I've tried a few options to solve in the past, and this is probably one of the more efficient ones that I've found in my exploration. Today I'll be using Dynamo for Revit 2022. Doesn't need to be in this version specifically, I've just been using it lately to make some training content, so I'm already in there. As well as this, I'll be using one custom package today to use one node, in this case the Genius Loci package, in order to assess the rotation of an element. So I hope this is a useful technique and helps you in assessing elements and their bounding boxes. So in this particular model, I've in this case created a set of walls and desks, so walls and furniture essentially. In Dynamo, walls are typically represented as a line when we look at something like their location. 2 points that determine a line, a start point and an end point. A desk instead is represented by a point or its family origin. So in this case, we're going to be looking at a method that can assess the rotation of these elements, because as you can see, a lot of these elements have been rotated against Project North, which is also Dynamo North. In this case, it's technically the internal north or the internal origins north facing direction. So if your project has a true north rotation, it's not going to be accounted for in how Dynamo interprets the rotation of its bounding box when it looks at it against the axes of Y. So in this case, we're looking at axes aligned bounding boxes. Now I'm just going to go into a floor plan for a majority of this workflow, just so we can see the impact in Revit of assessing a bounding box on a rotation. So in Dynamo, I'm just going to make a new script, and for now I'm just going to get all elements in active view. You may want to think about a different method if you're in a very large model, because that could collect quite a lot of elements potentially. You might want to use something like all elements of category in view, possibly. But in this case, I'm just going to work with all elements in view. So to begin with, we're going to get their geometry. So at the moment, we're just seeing them as elements, so they don't really have a 3D size at this point. So I'm going to use the element.solids node to do this. And now in Dynamo, we should actually have a representation for these elements. Now, for some reason, I've found that my 3D geometry seems to have bugged out in Dynamo, but I can see it in Revit, which is a bit strange. So you'll just have to keep an eye on Revit for the background preview in this particular video, but effectively you can see we've collected all these objects. Now, some of them do have more than one solid in them. For example, the desks all have multiple solids. So to join these together into one, we're going to use the union node. So we're going to use solid by union. And now we're going to have one solid per element. And this is assuming that they all have solids in them. As I go, I'm going to be turning off certain previews just as I go through the script, because by the end, we're just going to want to see the final bounding box that we get. So now that we have this solid, we can do a lot of things with it. We can check its bounding box. We could check the elements bounding box as well, but I think that the bounding box method for a single solid is probably slightly more computationally efficient. So I'm going to do that instead. So I'm going to get that piece of geometry's bounding box, and I'm going to convert that to a cuboid. So I'm going to use the toCuboid node. And as you can see straight away, here's the problem. We're looking at bounding boxes to the y-axis. So in this case, you can see that we're not actually assessing the element aligned bounding box. Some of them work if they're facing straight. So for example, this desk is aligned to the X and the Y axis, so it works, and so is this wall. But the moment that this wall goes against the axis, you'll see that the bounding box will then effectively have to counteract that along the axis. So what we're going to do instead is we're going to work around this. So we're going to take this cuboid and we're going to get its center. So we're going to use the solid centroid node, because we want to get this absolute center point of the element and then rotate it around that point. Now, there's a lot of ways to determine element rotation. One of the most robust nodes I found is in the Genius Loci package. The element get rotation node uses a lot of methods to determine the possible ways that an element can be rotated. So it assesses lots of different types of objects and runs them through a check process. And eventually, once it finds a relevant attribute or transform, it will tell you that rotation to the y-axis. So it's very reliable and it picks up a majority of scenarios. So I'm going to get all these elements rotation, and we should get a degree in this case, and we can use this to rotate our geometry and assess it in the orientation of the y-axis, and then rotate that element's bounding box back. So what I'm going to do is multiply this by -1, because we're going to rotate away from it first to get back to the y-axis. What I'm going to do now is rotate the elements. I'm going to get a rotate geometry node. So I think in this case, this is the one we want. We're going to rotate around a point. So we've got our geometry. In this case, our actual geometry is what we want. And our origin is going to be that solid centroid. The axis is going to be the z-axis because we want to rotate around the xy plane. And then the degrees are going to be that reverse of the element's rotation. So at this point, we now have the geometry of the element rotated so that it's orientated to the y-axis, which is what we can see here. Each of these has now been rotated into an orientation where a bounding box can actually measure this in an element aligned perspective. So I'm just going to go and copy my geometry bounding box to cuboid and just take these two nodes. And I'm going to do the same operation, but now instead I'm doing it in the orientation of the element itself. Now I'm going to go back and hide a few previews while I'm at it. Looks like that just hit them all. Very strange. But at this point, we're just looking at this element now, which is effectively the bounding box of the element, but now it's not rotated to the element. So what we're going to do is get another geometry rotate node, and we're going to take this cuboid, and again we're using the same origin and axis, but for the degrees we're now using the element's rotation. So we're counter-correcting that operation. If I just use a list.create node, we'll see that now we have the element's bounding box truly and correctly aligned to the element. And there we go. We can see we've done it. So if I go into 3D, check it out. We now have element aligned bounding boxes. So again, this is quite a heavy operation to run through. In this case, mainly because first of all, I'm getting all elements in active view. And from there, I'm also getting their solid geometry. So for a very detailed family in 3D, obviously the solids might be quite heavy. So just be mindful, you may want to reduce the number of elements you're dealing with at once, depending on the type of workflow you're using, where the bounding box is relevant. So once we have bounding boxes, or cuboids in this case, we can do a lot of things with them. We can check their width, depth, height, volume, all sorts of things. You might be looking at maybe the storage capacity required to pack these into a truck. Maybe that's one operation. Maybe you're just trying to use bounding boxes to intersect elements with each other, rather than relying on the element's solid geometry. So this might be a handy way to do that as well. This is a technique I use in quite a lot of programs. I also use this technique sometimes in programs like Grasshopper when I am trying to work with an element's rotation. That's a little bit harder because we're dealing with geometry in that case, rather than elements in Revit that have a rotation property. So typically in that case, what I do is I measure all the edges of an object and I find the most common facing direction of the element, and I use that to get it into a axis alignment, and then I rotate it back by the same distance. So it's a similar technique again, but I just remembered that it might be quite a heavy operation, but otherwise, element aligned bounding boxes. So there we go, just a quick little technique today, but I hope that it helped answer your question and gives you a new technique you can work with. If you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future similar videos. Thanks, take care.